Hi everyone. Today I would like to talk about security when you send your data through the network, encryption in transit, symmetric and asymmetric keys. But to start with, I would like to mention about the nature of networks. And it's important to understand that each and every request, each data that flows through the network, it can go through multiple hops, and especially in public networks, you cannot be sure who can read your data in between, or even theoretically can adjust your data, can modify your request and send a modified request to a receiver. So, and this comes out of the nature of the networks, because in networks, all the packets, they flow through many different hops, and it's not under your control. Even if you use safe protocols that make kind of tunneling in the network, it's not about making a safe tunnel that no one can get your data, get your internet packets. It's not about the control of data flow. It's all about encryption. So even though we cannot assure that no one can read data in between, we can always be using proper encryption approaches. We can always be sure that even if someone in the middle, a man in the middle, reads data, it's useless for them because they cannot decrypt it. And one of the well-known algorithms for encryption is SSL, but by itself, SSL is already outdated, so it's not used nowadays. And instead of SSL, we use TLS. So, however, the name of SSL, it's still used, but usually it would define TLS instead. TLS in most popular situations, it's used as a part of HTTPS protocol. So because HTTPS is HTTP, which is plain text plus encryption using TLS. However, TLS is used in many other cases as well, for example, encrypting your emails or encrypting messages in messengers and so on. So TLS is very, very widely used, but a core part is that you achieve the encryption of your data, of each and every packet that flows through the network, and only another party on another side of the network can decrypt it. This is achieved by using asymmetric keys, and I would talk about it a bit more, but in case of symmetric keys, it's one key that can encrypt and decrypt the data. But this key has to be shared with both parties of communication. And of course, if you start a new communication, you need to somehow send the key. And if you send it in a plain text through the network, if there is a man in the middle, then your key would be intercepted, and those persons in the middle would be able to decrypt all your communication, which is, of course, not desired. So TLS makes sure that this doesn't happen, and to achieve this, it uses asymmetric encryption. And now let's talk about symmetric and asymmetric encryption. In symmetric encryption, as I've already mentioned, you have only one symmetric key. This key is shared with both parties, and this key allows to encrypt and decrypt messages. So it's quite straightforward from the usage perspective. Symmetric encryption, comparing to asymmetric encryption, is much more efficient from computational point of view, so it works way faster. And if you establish safe communication, say in internet, you would prefer using symmetric encryption because you send many packets. You send a lot of messages. Much data flows and needs to be encrypted. And of course, it would be much faster to encrypt it using symmetric keys. But as I mentioned before, to pass a symmetric key, when a client generates a symmetric key and sends it to server, we need to encrypt it properly. So this is done using asymmetric encryption. And asymmetric encryption, it has two keys. In asymmetric encryption, we use two keys. One key is named private key, and another key is named public key. And if you own private key, you can encrypt data with private key and decrypt it with a public key, and vice versa. If you have public key, you can encrypt data with public key and decrypt with private key. So it's important to understand that if you encrypt data with public key, you cannot decrypt it back, and same for private key. So you need another key to decrypt it. By using asymmetric encryption, there are two main use cases that can be solved. One use case is you can imagine a mailbox, and if you have a public key, you can send some data, a letter, for example, the way as you would throw it into a mailbox. So you write a letter, you know what's inside, but after you throw it into a mailbox, no one can read it unless a person who has a key from a mailbox. And this is an owner of a private key. So from the other side, owner of a private key can achieve another use case. So from the naming, we know that private key is owned by one person and is a secret key. It's not shared with anyone. But public key it can be shared with many people, and this is not a secret key, basically. However, if a person has a private key, he can use it to sign his messages. So basically, it can be used in use cases when we need a signature or some kind of a stamp to prove that those message has been created by this particular person who has a private key. And this is achieved using an interesting approach. There are so-called hash functions. Using a hash function, we can take, for example, a message, apply a hash function, and get a way smaller string out of this message, which can be created only using the original message. So we cannot restore the message out of the string. But if we apply the same hash function to the same message, we would get the same string always. And it's important that if we change even one character in the original message, then the result hash key would be way different from the previous one. So what is done is that a person who is an owner of private key, he can write a message and then apply a hash function, get hash key, and then encrypt it using a private key. And then send original message in plain text. There is no need to encrypt it, just send it in plain text along with encrypted signature. On the other side, the receiver of the message, who owns public key, would receive a message in a plain text, so you can always read this message without any decryption. But if there is a need to prove that the message has been signed and never changed after it, it's always possible to apply a hash function on the message on the side of the receiver, get a hash key, and then take a signature that was encrypted using a private key, decrypt it using a public key, and compare both hash keys. They should be identical. However, if the message has been changed by someone in the middle, then they won't be identical. So, and this is a use case of digital signatures. At the end, if we talk about TLS algorithm, I won't go too much into the details. I only want to mention that in TLS algorithm, the aim is that client generates a symmetric key and passes it through the network in a safe way. And to do it, a client would use a public key to encrypt it. So to make sure that only an owner of a private key, which is a server, on the other side would be able to decrypt this symmetric key. And in future, symmetric key, when it's shared by both sides, can be used for safe communication. However, the way how server shares the public key with the client is done through so-called SSL certificates. And these certificates are signed by a trusted party, again using asymmetric encryption. So in case of TLS, there are two applications of asymmetric encryption. to sign the certificate and to pass a public key that is later used for encryption. And also TLS certificates uses asymmetric encryption to all future communications. That's it for today. I've talked about safe communications in networks, about asymmetric and symmetric encryption, about TLS. Thanks for listening, and bye-bye.